Hey everyone, this is Mayur. Welcome back to MLWorks. In this video, we'll be discussing about database scaling. It is quite an important topic in system design because whenever your number of users increases for your application, then there are a number of reads and writes happening to your database needs to be handled appropriately. So it needs to be scaled appropriately based on the number of read requests that comes into the database. So there are a couple of ways to scale the system. One is horizontal scaling, there is vertical scaling. So vertical scaling is where you have a single server and you keep adding resources to that single server itself or keep updating the single server. For instance, by adding CPU, RAM, disk to the same server. Okay, and you scale the system for the upcoming load. Now, when it comes to the horizontal scaling, okay, you have a single server, and as the load increases, you keep adding more servers instead of updating the existing server. So that's how it differs from vertical scaling. Now, Amazon RDS, okay, as said here, it provides right 24 TB RAM for a single database server. So it is quite expensive though. Okay, so that is one way of handling scaling of database. Okay, having about 24 TB RAM from scaling from what 1 TB RAM to what 24 TB RAM is one of the way to scale a system as the load increases. But there is some cons with respect to vertical scaling because you cannot keep adding what CPU or RAM to the same system or same server. Okay, and there is also a very good chance, since it is single server, there is a very good chance of single point of failure, and once it goes down, then you cannot do read write operations on your DB. And also having a single server with so much of GPU or CPU or RAM, okay, it is also quite expensive to use it. Okay, so what we do is we move to next horizontal scaling, which is also known as sharding. So where we what keep adding more servers to handle the load, and the sharding of database is nothing but what splitting your large database into small shards, and each of these shards have the same schema, and the data on each of the shard is what unique in nature. Okay, now how does what once you shard the database, whenever the request comes, it has to move to any of the shard. Okay, so how that is decided? Okay, so for that what we do is we use something called as hashing function or hash function, so which helps you to push the request to a specific shard such that it is evenly distributed. The data is evenly distributed across shards. So let's understand, right, what is the hash function is. So here if you see user ID mod of 4, okay, what we do is whatever the reminder that comes from the user ID, okay, it will be given to a specific shard. For example, user 0, okay, it will be sent to shard 1. User 1, it will be sent to shard 2. User 2, it will be sent to shard 3. User 3 will be sent to shard 4. So that's how what the cycle repeats. Okay, that's how you evenly what distribute the request that is coming in. So let's understand that again. So based on user ID, we shard the data across four small shards. Anytime you access the data, a hash function is used to find the corresponding shard. Now in shard 0, we have a set of users. For shard 1, we have set of users. Same similarly for shard 2 and shard 3. So as mentioned, we do mod function, which is your hash function here. Mod function we apply. And if result is 0, then it goes to shard 0. If result is 1, then shard 1 is, and likewise. Now, one of the important key thing about sharding is the user ID or the sharding key or the partition key is quite important because that will help you to decide how evenly you can distribute your request. Okay, so in this case, we use user ID as our partition key or sharding key. Now we can also use couple of columns to create a sharding key or partition key, and then decide how the request is sent to the specific shard. Now sharding key helps in what retrieving modifying data efficiently by routing database queries to correct database and selecting sharding key that evenly distributes the data. So we have to ensure we use a very good sharding key from our database, from our table, such that the requests are evenly distributed across all the shards. Now comes to the challenges of sharding. Okay, so in our previous slides, right, what we saw is we are using user ID mod of 4. Now that is a very simple strategy to what send request to the small shards. But what will happen is when if we use simple strategy, then we might have to what we might end up in a situation where we need to what reshard the data again. Okay, what do I mean by that, right? So there comes a stage, okay, where a single shard is completely full, okay, and you can no longer put data into that shard because that is the data is unevenly distributed. For example, shard 0 is completely full and shard 4 has no data itself. Okay, because of the rapid growth on that specific shard 0, and there is no users in that particular word shard 4. So as I mentioned, okay, when a single shard is no longer hold more data due to rapid growth, certain shards are exhausted due to uneven data distribution. If the shard is exhausted, sharding function needs to be updated and data needs to be migrated. So yes, so once a shard is full, so we have to ensure again that you create a new shard and then you create an update your what hash function such that this thing doesn't repeat, and you also have to move the existing data to the new shard as well. So to mitigate this problem, there is something called as consistent hashing technique that can help you in what evenly distributing the request coming from the user. Now there is, as I mentioned in the previous thing, right, resharding. So how does that happen, right? There is something called as celebrity problem, or also known as hotspot problem. So one specific shard is used excessively. Okay, by that consider you have celebrities. Okay, Taylor Swift, Lady Gaga, and all these people are stored. Their data is stored in a single shard. Now people will visit these websites or these profiles too frequently, and this will lead to what overload on that particular shard. So what is the solution for this kind of situation is you create a single shard for individual celebrity. Okay, so you can avoid having all the celebrities under the single shard and give each celebrity a separate shard, and such that the load is not overloaded on specific shard. Now comes join and denormalization. Okay, so once you have a database in a sharded position or sharded, right, in a sharded manner, so it becomes difficult for what performing join queries. So one of the way to handle such a thing is to do denormalization. So denormalization is nothing but keeping or redundanting the data set on the tables, okay, on your database. So that is one way to what handle having join queries on a single table, right? You can apply join on single table instead of what picking from multiple tables or multiple shards. Okay, so these are some of the things that you have to what keep in mind while you are doing database scaling. We have talked about vertical scaling, then we talked about horizontal scaling, what is sharding, what is the hashing function, how the data is distributed across small shards. Okay, what are the challenges? Okay, so with that, I'll be concluding this video. Thank you so much.